So active learning is a machine learning approach where we are able to reduce the number of instances an expert user needs to label. In different use cases, this expert user can be a different expert. For example, this could be a doctor trying to label data from radiology. And the biggest benefit of this approach is that we can reduce the cost for the expert users to label the data, and we reduce also the cost of training such a model because we will use less resources as we will have less data. For example, in the smart healthcare use case, we are trying to reduce the engagement of the expert users, which are doctors in this case, by using active learning technique. What we are doing is that we are asking this expert to take radiology reports, and these radiology reports are based on some imagery, some medical imagery of a particular pathology, and they are trying to convert this text, which is unstructured, into a structured form, which is a table. And for each of these radiology reports, they need to extract 119 different features. It's a lot of work, and if we can reduce this effort by 30, 40, or 50%, we can save them a lot of time, which they can use elsewhere much more efficiently. In the smart ticketing use case, we are having a similar kind of data, but in this case, we are working with the tickets that are issued by the users who have some problem with an IT system, and we need to dispatch those tickets to an appropriate team. So once we encounter a new class of these tickets, which encounters because we have new services or some new problem has occurred in general, we are able to build a classification model much faster than in traditional way because the user, the expert, the IT expert in this case, doesn't have to label all the data, but it would be just exposed to the data that is most relevant. On the other hand, when we are dealing with the smart energy use case, we are basically trying to reduce the amount of work that a computer has. We are trying to reduce computational cost. What we are doing there is we have a numerical model which is able to simulate the stability of an energy grid. And this model is computationally very demanding. And if we use it a lot, it also means a lot of stress on our IT infrastructure. So what we are trying to do, we are trying to learn a machine learning model that will be able to mimic this computationally very demanding model. And in a traditional setting, you would need to run this demanding model for all the data points in your phase space, while when we use active learning, the active learning will, of course, say, okay, this part of the space is not important, let's focus on the other part. And with this, we need to run this numerical model much less often, and we get almost the same accuracy of the model as we would with the traditional approach.